The big conceptual shift happening right now is moving AI agents beyond just conversation. We're
Mhm.
seeing them needing to get into real-world action.
Absolutely.
We're talking about AI agents that need to, say, manage your email or pull data from your company's private database, maybe execute some really specific high-stakes commands.
Yeah, it's a big leap.
It really started with simple function calling back in, 2023, where models could just output a JSON blob saying, okay, run this action.
Right, very basic stuff initially.
But as this whole ecosystem got way more agentic and, frankly, incredibly complex, that simple structure started to show some massive architectural fracture.
That fracture is really fragmentation. I
Mhm.
mean, for years, APIs, application programming interfaces, they were kind of the internet's shared language, right?
Mhm.
But when you shift to AI agents, you suddenly realize the models just lack a standardized common protocol for actually doing things for execution and for data fetching.
So, like, if your agent needed to check Google Calendar, then analyze inventory in some corporate warehouse, and then update a Jira ticket.
Yeah, you were building three completely separate, tightly coupled integrations. Each one needed its own custom business logic, unique authentication flows. It just doesn't scale when you start thinking about thousands of potential tools out there.
It sounds like every single time you wanted your AI to connect to a new service, you basically had to invent a proprietary new plug and, like, rewire the outlet from scratch.
That's a good way to put it.
You'd spend all your development time just wrestling with that integration boilerplate instead of building the cool AI features.
Exactly, it was a bottleneck.
Which is why Anthropic's move back in November 2024 was, potentially so critical. They open sourced the Model Context Protocol, or MCP.
And that right there is the subject of our deep dive today.
Hmm.
Our mission is really to unpack MCP. What is it actually? How does it standardize this messy process of AI to world communication?
And what does this new standard mean for how agents are going to operate in the future?
Precisely. So consider this your definitive shortcut to understanding what might be the next critical layer of the whole AI stack.
Okay, let's start with the big picture then. What exactly is MCP? I saw one source use this great analogy. It's like the USB-C port for AI applications.
Huh. Yeah, that analogy really hits the nail on the head. MCP is fundamentally an open protocol. It's designed to let external systems provide context and capabilities to AI models, but in a way that's crucially generalizable across integrations.
Generalizable, meaning you don't write custom code for every single tool.
Exactly. Instead of writing bespoke code for every API endpoint, the protocol standardizes the shape of how models call external tools, how they fetch data, and just generally how they interact with services.
Okay, I get the idea of a universal connector. That makes sense. But, it feels a bit ambitious. The developer world is constantly inventing new standards. Why should we believe this one will stick? Why not just use something existing like OpenAPI or Swagger to define the tools?
That's a really fair point. OpenAPI is fantastic for documentation,
Yeah.
absolutely. But it doesn't define the communication layer itself, like how the model and the tool environment actually talk back and forth. MCP does define that.
Okay.
And what's interesting is that MCP took quite a bit of inspiration from the coding world, specifically from something called the Language Server Protocol, or LSP.
Ah, LSP, right. That helps editors with things like autocomplete and spotting errors in your code.
Exactly. But MCP extends that concept pretty dramatically.
How so? What's the key difference?
Well, LSP is fundamentally reactive. It mostly just responds to a human developer typing away in their IDE, their integrated development environment.
Right.
MCP, on the other hand, is designed specifically for autonomy. The AI agent uses MCP to proactively figure out, often without any human intervention, which tools it needs to use, what the best sequence is, and how to chain them together to complete some complex mission you've given it.
And that autonomy piece must have implications for safety and control.
Absolutely.
Yeah.
Because these agents can operate on their own, MCP also had to formalize this concept of human-in-the-loop capabilities. It allows the main application, the one you're using, to prompt you, the human, for approval or maybe extra data right in the middle of a workflow. That's crucial for safety and just making sure things work correctly.
Okay, that proactive, autonomous nature, it sounds like it requires a very specific structure to work reliably. Let's dig into the architecture, because understanding how this standardized communication actually flows seems key to appreciating the stability MCP offers. You mentioned it relies on a client-server architecture.
Exactly. That client-server model, it gives you that necessary separation of concerns. So if you're trying to picture this, think of three main players. First, there's the MCP host.
Okay, the host. That's the AI application I'm actually interacting with, like Claude Desktop or maybe a custom app my company built.
Precisely. It could be a custom internal app, a model running locally on your machine,
Yeah.
or, yeah, a specialized UI like Claude Desktop. The host is kind of the overall coordinator.
And the host contains the next piece, which is the client.
Correct. Inside that host application lives the MCP client. Now, this client maintains a dedicated, persistent, one-to-one connection directly to a specific server. Its main job is to manage discovering what tools are available and then handling the request to execute them.
Okay. Host, client, and the third piece.
Finally, you have the MCP server. And this is the really crucial piece because it's the program that actually exposes the specific capabilities, the tools, the data to the client it's connected to.
But why bother with this explicit separation? Host, client, server. Why couldn't the host just talk directly to the tools? Seems simpler.
It really comes down to control and flexibility.
Yeah.
See, the server can run locally, right on your machine,
Right.
using a direct connection method they call Stdio Transport. That's super fast and secure for things like accessing your local files.
Okay.
Or the server can run remotely, somewhere else over the network, using something called streamable HTTP transport.
Ah, so that separation lets different teams own different parts.
Exactly. The team running the server, maybe the product team that actually owns the data and knows how to handle the authentication, that they can manage all those complexities. Meanwhile, the AI team building the agent can just focus purely on the agent logic. Model selection, prompt design, user experience. You get this true distributed ownership without getting bogged down in network details or where the tools physically reside.
Okay. This is where, like you said, the rubber meets the road, the actual language the models learn to speak. Our sources kept highlighting these three fundamental primitives or building blocks that MCP servers expose.
Yes, these primitives are absolutely key. They define the data layer, and importantly, they define the boundaries of control. The first one is tools.
Tools. Okay, so these are things the AI does.
Right. Think of them as active executable functions that the AI model actively chooses to invoke. Actions like book meeting or submit expense report. And they're designed with really strict JSON schema definitions. That ensures the model always sends the right parameters, correctly typed. The model is in control of when these get called.
Got it. Model controls tools. The second primitive is resources. How are resources different?
Resources are more passive data sources. They are application controlled, meaning the AI application, the host, reads them to get necessary context.
Like background information. Yeah, think about reading a database schema to understand the tables, or pulling in the content of a specific file, or maybe accessing API documentation so the model knows how other things work. They use these unique URI formats, like calendar.events 2024. And really importantly, they can use templates, like weather.forecast city date. This lets the model formulate smart contextual queries on the fly. Okay, so tools or actions the model takes. Resources or information the application provides for context. That distinction seems important for security too, right? Like read-only versus execute.
Exactly. Resources are often designed as read-only context, whereas tools are executable actions that change things. Big difference.
And the final primitive is prompts. Now, this is where the term might get a bit confusing because everyone listening probably associates prompt with the instruction you give to the LLM.
Right, and that's a good clarification. You shouldn't think of these MCP prompts as just raw text inputs. They're much more like structured interaction templates.
Templates, how so?
Well, these prompts are user-controlled, reusable templates. They define the expected inputs and the common interaction patterns for more complex, maybe domain-specific workflows. So, for example, you might have a plan a vacation prompt that's packaged up to require specific arguments like destination, duration, budget range.
Ah, so they help guide the agent.
Exactly. They let the server author, the person who knows the domain best, package up their expertise. It guides the agent towards the most effective way to use the available tools and resources for that particular scenario. It's like giving the agent a recipe.
Okay, that makes sense. And the communication backbone for all of this, tools, resources, prompts, it's all standardized using JSON-RPC 2.0 messages, which ensures everything talks the same language. What's maybe one fascinating technical detail about how that flow actually works?
Well, the protocol is really designed for consistency, especially in dynamic environments where things might change. After the initial handshake where the client and server basically negotiate versions and make sure they're compatible, the client can discover what the server offers using commands like tools list.
Sender discovery.
Right. But what's really neat is the use of real-time notifications. If, say, a new tool suddenly becomes available on the server because maybe an update was pushed,
Yeah.
the server can send an asynchronous notification straight to the client. So the agent's registry of available tools gets instantly updated. You don't need inefficient, time-consuming polling, asking anything new over and over. That immediate consistency is vital for these autonomous agentic workflows.
Okay, when we start seeing MCP in action, the use cases become immediately compelling. Like the developer-centric angle is a huge win. You hear developers complain all the time, ugh, I don't want to leave my IDE.
Exactly. And with MCP, you potentially don't have to. Imagine installing a Postgres MCP server. Suddenly, your coding agent, right within your editor, could execute read-only SQL commands to help troubleshoot a database issue.
Wow.
Or you could leverage something like a browser tools MCP server. That could give the agent access to a live, sandboxed browser environment, complete with console logs, perfect for debugging tricky web issues. It injects the context and the capabilities right where the developer is already working.
And this clearly extends way beyond just professional developers. I love the Blender example I read about. An amateur user, someone maybe terrified of complex 3D modeling menus,
Yeah, that was a cool one.
they could just use natural language, describe the complex 3D model they want to build, and the Blender MCP server acts as the interpreter, translating that natural language intent into the structured, executable commands Blender understands.
And that is the gateway to what people are calling composable AI. The real power here isn't just giving an agent access to one system. It's allowing the agent to intelligently combine specialized capabilities from different, maybe totally isolated, MCP servers.
So mixing and matching tools. Precisely. Think about combining, say, a local file system MCP server with a Slack MCP server. Suddenly, the agent can execute a workflow like, okay, find out who the last person was to edit this specific file, and then write them a message on Slack summarizing the recent changes.
How?
Okay. Two systems that were previously completely disconnected are now linked just because they both speak MCP.
That's the idea.
And this composability, it seems to translate directly into commercial value, too. Our sources pointed out this social media management tool, Monos, apparently it charges a pretty significant monthly fee.
Right. And the core of it is a large language model.
Yeah.
I think it was Claude Sonnet specifically.
Yeah.
But the real value, the reason people pay, is that it's running with something like 29 different MCP servers under the hood.
29, wow.
Yeah, composing tools for social scheduling, asset management, analytics, all sorts of things. The product isn't really just the model. It's the clever composition of all those specialized tools enabled by MCP.
And that must speed up development immensely.
Oh, dramatically. Because of that separation of concerns we talked about earlier, product teams can just focus on maintaining their specific tool, ensuring their data integrity, handling their own authentication protocols, all on the server side.
While the AI team focuses on the agent itself.
Exactly. The agent builder can focus entirely on model selection, prompt engineering, the overall user experience. Everyone gets specialized ownership. And that really drives development speed and, frankly, security, too.
Okay, so the future looks bright, especially now that we're seeing giants like OpenAI and Google indicating some level of support or interest. But MCT is still evolving, right? It's not perfect yet. What are the key barriers preventing immediate, widespread adoption, especially when we talk about remote servers connecting over the internet?
Yeah, it's definitely still solving some fundamental distributed computing problems. For remote, really scaled adoption, we absolutely need major protocol improvements, particularly around security. First off, authentication.
How systems prove who they are?
Right. MCP currently lacks a really standardized, unified mechanism for authenticating those client-server interactions. And maybe even more importantly, for securely delegating credentials to third-party APIs, using established methods like OAuth or API tokens.
So right now, every developer building a remote MCP server is kind of forced to invent their own security layer for connections, which sort of defeats the purpose of having a standard in the first place.
Exactly. It creates friction and inconsistency. And that problem just compounds when you get to authorization.
Okay, so not just who you are, but what you're allowed to do.
Precisely. The protocol lacks a built-in, standardized permissions model. Access control right now is often just session-level kind of all or nothing. You connect, you can do everything the server offers.
Which doesn't work for enterprise. Not at all. As soon as you scale up for serious enterprise use, you need much more fine-grained controls. Okay, this agent can read from this database, but it absolutely cannot write to it. That granularity is largely missing today. And what about dealing with complex actions? You mentioned agents chaining tools. If an agent has to execute, say, a 10-step process, what happens if step 5 fails halfway through?
Yeah, that brings us to the execution environment. MCP, as it stands today, is really focused on those communication primitives, tools, resources, prompts. It's not really a workflow management system.
So it doesn't handle the orchestration.
Right. It lacks a built-in concept for managing those multi-step tool calls. That means solutions for critical things like resumability if something fails, or automatic retries, or even just managing the state across multiple steps. All that has to be built externally on top of MCP.
Which again adds complexity for developers.
It does. And that needs to be standardized if these agents are truly going to handle critical multi-stage tasks autonomously and reliably.
And one more practical hurdle, just setting up new servers, is still a manual process, right? Finding and connecting to them isn't seamless yet.
It is, yeah. Discoverability is still manual. But the anticipation is pretty high that we'll see some kind of server registry and discovery protocol emerge. Eventually, think of it almost like an NPM, the package manager for JavaScript, but specifically for MCP servers.
Okay, so challenges remain. But looking ahead, let's assume MCP continues to gain traction, maybe overcomes these hurdles, and becomes the default standard for this kind of communication. How does that change the competitive landscape for companies building AI products or services?
Oh, it shifts things significantly. Yeah. Competitive advantage will likely evolve beyond just having the best API design. It will increasingly be defined by shipping the best collection of tools specifically designed for agents to use.
So not just having tools, but having better tools.
Better, more capable, maybe more efficient tools. Tools that are differentiated enough that an autonomous agent might dynamically select your tool over a competitor's offering based on its specific capabilities, not just because it's the only one available.
Interesting. And could this standardization lead to new pricing models too?
It very well could. You can imagine agents dynamically choosing tools based on a whole matrix of factors: speed, cost, relevance to the specific task at hand. This could lead to a much more market-driven, maybe even granular, tool adoption process, where tools compete on price and performance in real time.
And the design of the tools themselves, the things the MCT servers expose, that would need to change fundamentally, right? Moving away from just being developer-friendly to being more agent-friendly.
Precisely. Just exposing raw, low-level API functions probably won't be sufficient anymore. Tool design will need to become higher abstraction, more scenario-centric.
Can you give an example?
Sure. Instead of exposing, say, a dozen atomic functions for composing and sending an email, you might expose a single higher-level tool, like draft to mail and send. Why? Because that single function minimizes the number of back-and-forth turns the agent has to take with the server, which reduces overall latency and complexity for the agent. Tool design will increasingly be optimized for machine efficiency, not just human readability.
Okay, so to bring it all back together then, the Model Context Protocol, MCP, is essentially this emerging blueprint for standardizing the language of communication between AI agents and the outside world, all the tools and data they need to interact with.
That's the core idea. It aims to replace all that fragmented, custom-built integration logic with a single open standard.
Providing that clear client-server architecture and those three key primitives, tools, resources, and prompts, which really seem to set the stage for more autonomous, multimodal, and just deeply integrated AI experiences in the future.
It really feels like a foundational change for the AI industry, or at least it has the potential to be. And, if MCP truly takes off, it raises this final provocative thought for you, the listener, to consider.
Go on.
In the future, the design philosophy that really wins out might not just be about having great data or a great model. It might be about how well you design the tools and, critically, the documentation for those tools, specifically for machines, not just for human developers. Designing for the agent becomes paramount.